Welcome friends, in this new video we see Bessel's interpolation formula. The Bessel's interpolation formula we need Gauss backward formula. The Gauss backward formula is here. I will write the Gauss backward formula. Gauss backward formula is yu equal to y0 plus c1 in delta at y at minus 1 plus u plus 1 c2 delta square y at minus 1 plus u plus 1 c3 delta cube y at minus 2 plus u plus 2 c4 delta raised to 4 y at minus 2 plus like this. In this Gauss formula, the value of u is x minus x0 divided by h. Now here we shift the origin to 1, origin to unity, origin to unity. That means that is 0 to 1. We are shifting this origin to 1. Then here we write this u as x. When we change this u to x minus x1 divided by h. So we have now x minus x0 plus x0 minus x1 divided by h equal to x minus x0 divided by h minus x1 minus x0 divided by h. This is our new u. Okay. So new u equal to this old u, and x minus x0 is h. So this u minus 1. Here therefore this new u dash will be changes to u minus 1. The value of u dash will be u minus 1. Hence wherever u in the Gauss backward formula, we shift this u to u minus 1. Then this Gauss backward formula will be yu equal to y0. So y0 will shifted to y1 plus u is shifted to u minus 1 c1 delta y at minus 1. Look at this, 0 is shifting to 1. So minus will be shifted to 0, minus 2 will be shifted to minus 1. In this manner, this y at minus 1 will shift to 0 plus u plus 1. So this will be u c2 delta square y at 0 plus u plus 1 u c3 delta cube y at minus 1 plus u plus 1 c4 delta raised to 4 y at minus 1 plus. Let us call this as equation number 1. Now the Gauss forward interpolation formula. The Gauss forward interpolation formula, yu equal to y0 plus u c1 delta y0 plus u c2 delta square y at minus 1 plus u plus 1 c3 delta cube y at minus 1 plus u plus 1 c4 delta raised to 4 y at minus 2 plus. Let us call it as equation number 2. Now add 1 and 2. If we add 1 and 2, then we obtain here y 2yu equal to y0 plus y1. Here delta y0, so coefficients u minus 1 c1 plus u c1 into delta y0 plus look at this u c2 u c2, so u c2 coefficient is common and the remaining is delta square y0 plus delta square y at minus 1 plus delta cube y at minus 1 is common, hence coefficient, addition of coefficient u c3 plus u plus 1 c3 into delta cube at y at minus 1 plus now here u plus 1 c4, u plus 1 c4 is a common term, u plus 1 c4 common, and we have delta raised to 4 y at minus 1 plus delta raised to 4 at y at minus 2. So friend, remember this procedure is very simple. What we have done here, we have written the Gauss formula, Gauss backward formula, then we have shifted the origin to unity, that is 0 to 1. So whenever 0 shifted to unity, minus 1 shifted to 0 and minus 2 will be shifted to minus 1 likewise, and this new u dash will be shifted to u minus 1, and for these changes the Gauss backward formula will changes to this one, yu equal to y1 plus u minus 1 c1 delta y0 plus u c2 delta 2 y0 plus u c3 delta 3 y at minus 1 plus u plus 1 c4 delta 4 y at minus 1. Then let us call it as equation number 1. We have written the Gauss forward interpolation formula, then we have added these two equation and we get this new equation. So u minus 1 c1 means u minus 1 and u c1 means we have u. So here we get 2u, this will be 2u minus 1. Hence this formula, let us write in simplified forms. This term of this Gauss addition of these two equal to 2yu equal to y0 plus y1 plus 2u minus 1 into delta y0 plus here uc2 means what, u into u minus 1 divided by 2 factorial into delta square y at 0 plus delta square y at minus 1 plus uc3 means u into u minus 1 into u minus 2 divided by 3 factorial plus u plus 1 c3 means u plus 1 into u minus 1 divided by 3 factorial. So common terms are u and u minus 1. Taking this common, u into u minus 1 divided by 3 factorial, and what remains, u minus 2 plus u plus 1. So we have now this 2u and minus 1. Hence u into u minus 1 into 2u minus 1 divided by 3 factorial into delta 3 y at minus 1 plus u4, u plus 1 4. So this is u plus 1 into u minus 1 into u minus 2 divided by 4 factorial into delta raised to 4 y at minus 1 plus delta raised to 4 y at minus 2 plus like this. Now dividing by 2 throughout. So yu equal to y0 plus y1 divided by 2 plus dividing by 2 to these terms we have u minus 1 by 2 into delta y0 plus we write this u into u minus 1 divided by 2 factorial into delta square y0 plus delta square y at minus 1 divided by 2 plus here this 2 we divide 2 by 2 to this term, this factor. So, u into u minus 1 into u minus 1 by 2 divided by 3 factorial into delta cube at y minus 1 plus this term removing this. So, the plus term next will be plus u plus 1 into u minus 1 into u minus 2 divided by 4 factorial into delta raised to 4 y at minus 1 plus delta raised to 4 y at minus 2 divided by 2 plus like this. So, whenever there is a odd term, look at this, here is a odd term, we have the factor u minus 1 by 2, and whenever there is a even term, here 2 factorial, 4 factorial, there is a no u minus 1 by 2 as a factor. So, likewise, if we write the general term of this formula, we have now u plus k minus 1 u plus k minus 2 dash dash u minus k divided by 2k factorial 2k factorial. So, there is a division as mean of these two terms, there will be mean 0 and minus 1 and minus 2. So, likewise there is a mean delta raised to 2k y minus k plus delta raised to 2k y minus k plus 1 divided by 2 plus, and whenever there is a odd term, there is a one factor is a u minus 1 by 2. So, the other factor or general term of this is u minus 1 by 2 as a one factor, then u plus k minus 1, u plus k minus 2 dash dash u minus k divided by 2k plus 1 factorial into delta raised to 2k plus 1 into y at minus k plus. So, this formula is known as Basels formula. This formula is known as a Basels interpolation formula, and it is very simple. How we have derived? We have used the Gauss interpolation formulas, backward and forward interpolation formulas. In the backward interpolation formula, we have shifted the origin to unity, and then that the revised formula is taken for addition, and then we have derived the Basels interpolation formula. Thank you friend, thank you for watching this video.